Hello everyone, my name is Horo Tanyo Patrick, alumni of the Pan-African University Institute of Powers. It's a big pleasure for me to be associate of the 6th United Nations Conference on Space Technology for Water Management, where I'm going to present you integrating GIS for water flood climate nexus assessment, a case study of the Upper Bandama Subwatershed in Ivory Coast. In introduction, you have to notice that Ivory Coast is essentially an agricultural nation. And according to the National Development Plan, agricultural sector represents more than 90% of the national GDP and employs 65% of the active population. Add to that, 65% of water needs for agriculture, 23% for industry, and 12% for the communities. That being 39 billion cubic meter of surface water for agricultural irrigation is to ensure the food security according to the Ministry of Water and Forest. In plus of that, water resources have experienced increasing scarcity in the recent decades. And this situation is projected to be worse by 2100 with a prediction of stable precipitation and an increasing temperature to 3 degrees Celsius, especially in the northern part of the country. So about 4% of the Ivorian population is in a situation of food insecurity, according to the World Food Programme in Ivory Coast. This combined action of climate variability, demographic growth, and rapid urbanization and agricultural expansion is evaluated to exert a strong pressure on the long term of the viability of water resources. That's why you ask this question: how can GIS, as a tool, analytic tool, can be used to evaluate the water food climate nexus in the Upper Bandama watershed, and how can those results help to develop strategies for sustainable natural resource management in the Upper Bandama watershed. The objective of this study is to harness the power of geography information system to evaluate the water food climate nexus in the Upper Bandama watershed and utilize the findings to formulate strategies for sustainable natural resource. In the methodology, we use Landsat satellite images of 1990, 2005, and 2020 to assess the spatial-temporal dynamic of land use and land cover. Then, we use agricultural yields and agricultural production for the analysis of food security. And to finish, we use also the annual and seasonal analysis of temperature and rainfall for Nicholson and Angot tests have been used for the climate analysis. All those data have been integrated in the GIS for spatial analysis, for requests, and for some geostatistic processing. As a result, we found that general and rapid transformation of different environmental components between 1990 and 2020. We noticed also an expanding agricultural activities confirmed by the FAO study. So, the annual precipitation between 2008 and 2020 is increasing. An area characterized that by seasonal and internal climate instability, as Horo and Horo study mentioned in the study. We can also notice a decreasing of yields, both of cash crops and subsidized crops, show that more surface are consumed for fuel production. That characterizes an expansion of the agriculture. And to finish, we use the principal component analysis to apply to water, to food and climate parameters. Those results show that a strong correlation between precipitation, temperature, and humidity influencing the agricultural production. To conclude, this study examines the critical connection among water management, food security, and climate change in the Upper Bandama sub-basin, underscoring the importance for regional sustainability. It identifies significant variability in water resource in the impact of crop concentration on surface water in the region, alongside a notable decrease in the rainfall over the past decade, coinciding with demographic growth and increasing agricultural production. Then, the research emphasizes the vital link between food security and climate, advocating for the development of adaptive strategies that include the participation of all stakeholders due to the challenges posed by limited data. In recommendation, we are made for achieving sustainable agricultural yields through adaptive strategies and the development of collaborative policies aiming for a prosperous and sustainable future in the region. Here in this slide, we have some recommendations that we did. And those recommendations is around the GIS, institution collaboration, and climate change adaptation. Thank you so much for your attention. I'm available for any recommendation and collaboration. Thank you.